Hello, welcome to the next installment of the Chapter 21 lecture videos. This video is going to cover drop factors, and this begins on page 331 of your textbook if you're trying to follow along. So we're going to utilize drop factors when we are preparing sterile products. We're going to calculate the rate of the IV administration. These calculations are going to be expressed as drops per minute, or DTS over minutes. And we're using this to express the volume of medication that is to be administered each minute. Various IV administration sets are going to release specific drops per milliliter. This is your drip rate. The simpler way to state the drip rate is by drop factor. And we'll get into what we mean by that in just a second. So let's first look at the illustration at the bottom of page 331, figure 21.1. This is the illustration of drip sets. And you see each one of these drip shapes is representing 1 milliliter. And the circles inside of each drip is representing how many drops are in each of these drips. So the standard or macro drop calibrations allows for 10 drops per milliliter. You see those drops are pretty good size. Next one in the middle, we have the 15 drop per milliliter. You see those droplets are slightly smaller than the 10 drops per milliliter. And then even smaller than the 15 drop per ml is the 20 drop per ml. And then on the far right-hand side there, you have the 1 milliliter that is containing 60 drops per ml. This is your micro drop calibration. So when we were talking about your drip rate being expressed more simply as a drop factor, you see here along the right-hand side, you have drip rate of 60 drops per ml. Your drop factor is 60. Your drip rate is 20 drops per milliliter. Your drop factor is 20. 15 drops per ml, drop factor is 15. And 10 drops per ml, your drop factor is 10. So you see it is just easier to say that your drop factor is 60, 20, 15, or 10. So again, these are expressed as drops per minute. So those are the units of measure you're going to wind up with when you go to canceling out your like units. You're going to want to wind up with drops on your numerator side and minutes on your denominator side. This drip rate is going to determine how the IV pump is calibrated. It also determines the volume of medication to be administered each minute. We looked a little earlier in a previous video at the volume per hour. This is basically looking at the number of drops or the volume occurring in each minute. So our micro drip sets are calibrated to deliver 60 drops per milliliter, and this is the most common drop factor. Anytime an equation does not tell you what your drop factor is going to be, you are to presume that it is 60 because this is the most commonly used. If it's not 60, they should be stating it within the problem. So your micro drip sets can be calibrated to deliver 10, 15, or 20 drops per milliliter. The more drops per milliliter means smaller drops within that 1 milliliter, because again, 1 milliliter is still 1 milliliter, regardless of the number of drops contained within it. So this is just another way of expressing your drop factors. Again, we have those 10 drops per milliliter. It's a drop factor of 10, 15 drops per milliliter is a drop factor of 15, 20 drops per milliliter is a drop factor of 20, and 60 drops per milliliter is a drop factor of 60. So let's look at an example. And this is on page 332, example 21.21. And we are told that a 1 liter bag of D5W is to be administered at a drop factor of 60 over 6 hours. What is the flow rate in drops per minute? So let me turn off the screen share so that you can see what it is I'm fixing to do on the board. So we're going to do these a little bit differently than we did the other linear equation problems, where we were starting with the fact that we had a 1 liter bag and we were setting that up over 1. With this particular example, we're going to start by looking at the information or facts that we know, and we know that we have 1 IV bag and that it contains 1 liter. We know that there are 1,000 milliliters for every 1 liter. Our word or our information told us that the drop factor is 60. So there are going to be 60 drops administered per milliliter. And the duration of the administration is 6 hours. And there are 60 minutes in 1 hour. So we're going to use the principle of dimensional analysis and we're going to solve this problem. Now, again, like I said, we're not starting out with the 1 liter over 1. We're not starting out with a bag over 1. We're going to go ahead and do that conversion before we even begin to work our problem. We know that we have a 1 liter bag and that 1 liter is 1,000 milliliters. We also know that this is being administered over 6 hours. They told us that our drop factor is 60 drops per milliliter. And we also know that for every 1 hour, we have 60 minutes. And we do that because we remember we've got to get to drops over minutes. So we had to get those minutes in there so that we can get our answer where we need it to be. I do apologize for the glare. I hope you're able to see and make out what the numbers are. I have 3 fractions. I have 1,000 ml over 6 hours, 60 drop over 1 ml, and the 1 hour over 60 minutes. Now I'm going to come back through and I'm going to cancel out my like units. So I can lose my milliliters. And even though they are on opposite ends of the equation, they're still diagonal. One's a numerator, one's a denominator. So I can lose the hours. And I can also cancel out any like numbers. So we can lose the 60s. We can lose these ones. And that leaves you with 1,000 divided by 6. And if you plug that into a calculator, it gives you 166 point and a whole bunch of 6s. We cannot deliver or administer or calculate for a part of a droplet. So when we are talking about drops per minute, you're going to round your answer to the nearest whole number. And in this case, that was 167. So there are 167 drops being administered per minute if we are delivering 1,000 mLs in 6 hours. Let's go ahead and look at example 21.22. They're on the same page, 332. That example says we have 500 ml is to be administered to a patient over 5 hours using a drop factor of 15, which is the flow rate in drops per minute. So we're going to start the same way, only this time we didn't have to do a conversion. They tell us already in milliliters what is being administered, and that's 500 milliliters. And we are administering this over 5 hours. My drop factor is 15. So that means that we are delivering 15 drops for every 1 milliliter. And again, I've got to get some minutes. And so I know that for every 1 hour, I have 60 minutes. So that's how your equation would set up. And then we're going to come through and we're going to cancel out these like units of measure so we can lose the milliliters. And again, even though they're on opposite ends of the equation, we can still lose the hours. Then we can lose any like numbers. And on this particular occasion, the only number we can lose are the ones. So on the top, that leaves me with 500 times 15, which is 7,500. And on the bottom, it left me with 5 times 60, which is 300. And you see up here at the top, I apologize, I did not point out, but we were left with the drops as our numerator and minutes as our denominator. But now we're down here and we had 7,500 divided by 300. Which comes to 25. And again, that's drops per minute because those were the units of measure we were left with. Drops per minute, 25 drops per minute. And we'll look at example 21.23. I'll try another color marker and see if it shows a little better. 21.23 says we have an RX of vancomycin, 250 milligram per 250 ml. We are dispensing 500 milligrams over 3 hours, every 8 hours, and they're asking us what is the flow rate in drops per minute. So they're providing or presenting this problem to us a little bit differently than they provided the others. If we're going to administer 500 milligrams and it comes 250 milligram per 250 ml, how many milliliters are we going to have to dispense to achieve the 500 milligram dosage? I'm going to need to dispense 500 milliliters, correct? It was 250 milligram per 250 ml. If I need 500 milligrams, then I need 500 ml. There's my 500 ml. It also says that we're doing this over 3 hours. And it says, what is the flow rate in drops per minute? They did not provide a drop factor. So what are we going to presume our drop factor is? Be 60 drops per 1 milliliter. Anytime they don't tell you what it's going to be. And then again, we've got to get to minutes. And we know that for every 1 hour, we have 60 minutes. Now I can cancel out my like units. So again, I'll lose my milliliters and I can lose my hours, even though they're on opposite ends of the equation. Now I can lose like numbers. So we can cancel out these ones. And in this case, we can cancel out the 60s. You'll notice for the units of measure, I'm left with drops as my numerator and minutes as my denominator. That's where we're trying to get to, right? So now on the numerator side, the only number I'm left with is 500. And on the denominator side, the only number I'm left with is 3. So 500 divided by 3. And remember, we have to go to the nearest whole number because we cannot deliver a partial droplet. That is 167 drops per minute. Rounded it up to the nearest whole number. We'll go ahead and look on page 333 to example 21.24. Example 21.24 says we have a 100 ml bag containing 1 gram of Zanusor is to be infused with a drop factor of 15 over 1 hour. What is the flow rate in drops per minute? So we know that we have 100 milliliters being administered over 1 hour. Oh, that color is real hard to see. Let me try another one. Sorry about that. That color is a little bit easier to see. Apparently, I need to get some more markers in here. All right, so we have our 100 mLs being administered over 1 hour. We are also told that our drop factor is 15. So that means that we are delivering 15 drops for every 1 milliliter. And we are trying to get this 2 drops per minute. So we know that for every 1 hour, we have those 60 minutes, right? So again, we're going to cancel out our like units of measure. I'm going to lose my milliliters. We're going to lose the hours and any like numbers. So I can lose the ones. And looks like that's about it on this one. I'm left with drops as the numerator and minutes as the denominator, which is where I'm headed. Now 100 times 15 is gonna be 1,500, right? 1 times 60 is 60. I apologize. Trying to avoid that glare. There we go. And if we divide 1,500 by 60, it'll give you 25 drops per minute. And they have one more example for us for these, so let's go ahead and work that one as well. Let's look at example 21.25, still there on page 333. Example 21.25 says we have an RX for 2 grams of Mandol in 1 liter of D10W over 4 hours TID. What is the flow rate in drops per minute? So if we have 1 liter, how many milliliters do we have? 1,000, right? And it also told me in my scenario that this is being administered over 4 hours. It also tells me what is the flow rate in drops per minute. So they're not giving me a drop factor. So which drop factor am I going to use? $60 drops per 1 ml. And then we've got to get to minutes. So we know that for every 1 hour, we have those 60 minutes. Now I'm going to cancel out my like units of measure. We'll lose the milliliters. We'll lose the hours. I'm left with drops as the numerator and minutes as the denominator. I can go ahead and cancel out any like numbers. We can lose the 60s and these ones. And it literally leaves you with 1,000 divided by 4. Which equals 250 drops per minute. So this is drop factors. I hope this video has helped you out and get you through the assignments and the homework. I hope you understand and that it's been clear. If anything seems muddy at all, or you're not 100% on how to go about doing something, please reach out to me. That is what I'm here for, to help you learn this and master it. You've got to get through your national exam, and this math is on that test. Again, just simply reach out if you feel like you need me. And until we see each other again, bye-bye for now.